Good evening children, welcome back, welcome to Yupp Master, the school foundation program. So, in previous class we have gone through the chemical formula writing session. So, how we are going to write the chemical formula? We have learnt it by taking the valency of the atoms involved in the molecule. So, we have seen some examples with respect to the writing the chemical formulas. So, let us today focus on some more concepts related to the chemical formulae, and then we will focus on the mains level as well as advanced level questions that are given from the scope of chemistry, the basic concepts of chemistry. Okay. So, let us move on to the some of the formulas that we are going to write based on the names that are given to us. Okay. So, here if you observe, the compound name is given and we have to write the formula. Sodium carbonate. So, sodium symbol yesterday we have seen it is represented with Na. Carbonate is with CO3 minus 1. Okay. So, when you look at the valency of sodium is 1, carbonate valency is also 1. So, just interchange the valencies when they are same and write the formula. So, actually we have to write the valency and then look for the highest common factor and then divide the valency with the highest common factor to get the simplest whole number ratio. Once you get the simplest whole number ratio, then exchange the valencies of one with the other. So, automatically you will end up with the formula of the compound. So, here the highest common division for the sodium and carbonate, it is coming out to be the same. Okay. Here here if you observe the carbonate, it is valency is 2. So, we are going to take the valency as 2, CO3 minus 2. Okay. CO3 minus 2 and Na. So, if you go for the dividing with the common factor, so the simple ratio that we are going to get is 1 is to 2 only. 1 is the common factor. Here the carbonate valency is 2 CO3 minus 2, since it has minus 2 charges. So, the valency will be 2 only. Okay. So, if in this case what you have to do, we have to exchange the valencies of carbonate to sodium and valency of sodium to the carbonate. So, in that case if I am exchanging the valency of carbonate to sodium and sodium valency to carbonate, we can write the formula as Na taken 2 times CO3. Na2CO3 is the formula of sodium carbonate. Okay. Next is sodium bicarbonate. So, sodium bicarbonate, in that case we are going to take the bicarbonate. Bicarbonate is presence of one hydrogen with the carbonate CO3, and in that case the charge will be minus 1. Okay. So, if you observe here the valency of sodium is 1 and bicarbonate ion valency is 1. So, bicarbonate valency is 1, sodium valency is 1. So, simplest whole number ratio will be 1 is to 1, there is no doubt, and exchange the valency of sodium with carbonate and bicarbonate and valency of carbonate with the sodium. Okay. So, since it is 1 and 1 is the ratio for the two species involved here, so we can write it as NaHCO3 is the formula of sodium bicarbonate, sodium carbonate and sodium bicarbonate, right. Now, looking at the other one, the next compound that is given is sodium hydroxide. Sodium hydroxide, if I want to write the sodium hydroxide, we know the hydroxide is OH minus 1, OH minus 1. Okay. So, if you look at the valency, sodium valency is 1, hydroxide valency is 1, both the valencies are 1, highest common factor is 1. So, the simple ratio you are going to get is 1 is to 1. So, exchange the valency of sodium to the hydroxide valency to sodium, sodium valency to hydroxide. So, 1 and 1. So, if I am going to write the formula, so we can get the formula as NaOH. NaOH is the formula of sodium hydroxide. Okay. Next we have a copper sulphate. Copper sulphate. So, now copper sulphate we can write the copper symbol and sulphate ion symbol as copper we know it is Cu, sulphate is SO4 minus 2, okay. SO4 minus 2 is the sulphate ion, copper is Cu, okay. And we know the valency of copper is 2, okay, and valency of sulphate ion here minus 2 charges, so it is valency will be 2, okay. So whenever we have ion, take the ion charge, the whatever may be the charge that is present, it is a positive charge or negative charge, do not bother about the sign, it is positive or negative, only take the numerical value as a valency, okay. Sulphate valency is 2, copper valency is 2, okay. Now dividing with the highest common factor is 2. So when divide with the 2, we are going to get copper valency as 1 and sulphate valency as 1. So in that case, what we have to do? Exchange the valency of sulphate ion to copper, and similarly exchange the valency of copper with the sulphate. So it is 1 and 1 in both the cases. So we can clearly write here as the formula for the copper sulphate. Copper sulphate is CuSO4. CuSO4, because the valency for sulphate ion is 1, so Cu I am taking one time. Copper valency is 1, so I am repeating SO4 only one time. So Cu one time, SO4 one time. So in order writing 1 over there, I am ignoring it. Whenever we have a valency 1, generally ignore the valency 1 and write the formula, okay. Right. Silver nitrate. Silver nitrate. So nitrate, if you observe, we can write the symbols of silver and nitrate as silver is Ag, nitrate is NO3 minus 1, silver is Ag. So silver generally exhibit a valency 1. So first write the valency of silver. Silver valency is 1, nitrate valency is also 1. Okay. So, 1 is the valency of silver, 1 is the valency of nitrate ion. So, in this case, if you take the highest common factor and divide it with the valency with the highest common factor and get the simple ratio, we are going to end up with the simple ratio as 1:1. So, exchange the valency of nitrate with silver, silver valency with the nitrate ion. So, in that case, what we are going to get? We are going to get the formula as AgNO3, Ag taken one time, NO3 taken one time. So, AgNO3 is the formula of silver nitrate. So, we can write this way the formulas of the compounds. Let us see some more examples. Hydrochloric acid. Hydrochloric acid. Hydrochloric acid, we know hydrogen and chlorine, and valency of hydrogen is 1, chlorine is also 1. So, just exchange the valency of chlorine to hydrogen, valency of hydrogen to chlorine. So, H is taken one time, Cl is taken one time. So, I am not writing the one symbol in the case of writing the formula. So, I am directly writing as HCl, hydrochloric acid. But looking at the sulfuric acid, the formula that we can write here is SO4 minus 2. So, SO4 minus 2 is the sulphate ion, okay, and when you observe the valency of hydrogen is 1, sulphate ion valency is 2, okay. Now, take the highest common factor is 1, okay. So, the simplest ratio that we are going to get for the hydrogen and sulphate ion is 1:2, okay. Now, exchange the valency of hydrogen to sulphate ion. So, I am taking the valency of hydrogen as a number of times of sulphate ion. Similarly, valency of hydrogen, sulphate ion valency I am taking for the hydrogen. So, it is taken, H should be taken 2 times, sulphate ion should be taken 1 time. So, when we write the formula, what is the formula that we are going to get? So, H is taken 2 times, so it is H2, SO4 taken 1 time, so I am writing it as SO4 only. So, H2 SO4 is the formula for sulfuric acid. Nitric acid. So, in the case of nitric acid, nitrate ion has to be taken. So, writing the nitrate ion just now we have seen silver nitrate, it is NO3 minus 1, Okay. So, when you observe the valency of hydrogen is 1, nitrate ion valency is also 1. When you look at the highest common factor is 1. Dividing the valencies with higher common factor, the simplest ratio that we are going to get between hydrogen as well as nitrate ion is 1:1. So, exchange the valency of nitrate ion to hydrogen and valency of hydrogen to the nitrate ion. So, what we are going to get? Hydrogen should be taken one time, NO3 should be taken one time only. So, when we are having 1 in the valency, it has to be ignored. So, just we write as HNO3. So, HNO3 is nitric acid, HNO3 is nitric acid, right. Next is ammonium chloride. Ammonium chloride. So, if I take ammonium ion and chloride ion or the chlorine, so we can write it as ammonium ion is NH4 plus. We have seen while we are dealing the compound ions and simple ions. Okay, NH4 plus is ammonium and chloride is chlorine. Okay. So, when you observe the valency here, the charge is +1. So, valency is taken as 1 for this ion. Chlorine generally exhibits valency 1. So, we have a simple ratio of 1:1 between ammonium ion and chloride ion. So, automatically exchange the valency of chlorine with ammonia and ammonia valency to chlorine. So, in that case what we are going to get? The formula: ammonium ion should be taken one time, chlorine should be taken one time. So, we can write the formula as NH4 Cl, NH4 taken one time, Cl is taken one time. So, ammonium chloride is NH4 Cl2. Okay. Sorry, NH4 Cl is the formula, NH4 Cl, ammonium chloride, right. Next is potassium dichromate. Potassium dichromate. So, potassium generally represented with K, not with P. So, the element P representation is for the phosphorus. Okay, we use P for phosphorus representation. So, for potassium we have to use potassium is K. Okay, dichromate Cr2O7 minus 2. Cr2O7 minus 2 is dichromate. So, when you observe the valency of potassium, alkali metal, it is valency is 1, dichromate ion having a valency 2. So, potassium dichromate formula if I want to write, first of all the valency has to be divided with the highest common factor. In highest common factor for the potassium and dichromate ion is 1. So, dividing with the highest common factor, the simplest ratio what we are going to get is 1:2. Okay. So, now what you have to do? Exchange the valency of dichromate ion to potassium, and similarly exchange the potassium valency to dichromate ion Cr2O7. Okay. So, in that case we have to take potassium 2 times, chromate ion should be taken 1 time. So, what will be the formula that we are going to write in this case is potassium taken 2 times, so it is K2 Cr2O7. Cr2O7 dichromate ion is taken 1 time, so I am writing as Cr2O7 as single species, but K I am repeating 2 times, so I am writing it as K2 Cr2O7. K2 Cr2O7 is potassium dichromate. Then potassium permanganate. Potassium permanganate, if you observe, permanganate ion is MnO4 minus 1. MnO4 minus 1 is the permanganate ion. So, when we look at the valency, here the valency is 1, here the valency is also 1, because MnO4 having a negative charge, 1 negative charge. So, take that value as the valency. Potassium valency is 1, MnO4 valency is also 1. So, now when we divide the with the highest ratio, highest common factor, the simplest ratio that we are going to get is 1:1. So, now exchange the valency of MnO4 to potassium, similarly potassium valency to MnO4. So, in that case what we are going to get as a product or the formula for this particular potassium permanganate. Potassium permanganate formula is given as K, since it is exchanged with 1. So, I am not writing 1 here, K MnO4. MnO4 is also to be taken one time, so I am writing as MnO4 only. So K MnO4 is the potassium permanganate. So potassium dichromate is K2Cr2O7. Potassium permanganate is K MnO4. Mn is manganese, okay, manganate, potassium permanganate, potassium dichromate, ammonium chloride, nitric acid, sulfuric acid, hydrogen chloride. So all the formulas we can write easily by taking the valency and dividing the valency with the highest common factor in order to get the simplest whole ratio, and then after getting the simplest ratio, then exchange the valency of one ion with the other ion, so that you can end up with the formula. So this method of writing the chemical formulas is known as criss-cross method of chemical formula writing, okay, right. So of course, it is very simple. Once you start practicing the number of compounds, you can easily understand. Actually, we have discussed in the previous class so many examples, the same things were repeated here, but of course, one or two new components we have written the formula. So writing the formula is very easy. Just look at the valency, based on the valencies we can write the formula. Still, if you have any doubts in writing the formula of any of the compound, just send me the question through the question and answer the facility that is available through the Yupp master, okay, right. Now let us focus on some of the questions that are appeared in the main and as well as advanced level questions. So here based on the basic concepts of the chemistry, what we have discussed so far, the basic components and the basic chemistry what we have learned so far, based on that some of the questions were given. So I brought some questions to you people, so that you can identify how the questions will be asked in the examination and how you can easily handle those questions, okay. The question is given, the atom was electrically neutral because we have discussed that atom is neutral, ion is charged particle, but atom is neutral. So atom is neutral, why it is neutral? In the last class we have discussed that atom. So whenever we represent the atom, let us say A is an atom here. So whenever we write atom, we write the symbol as A only, we won't show any positive or negative charges here. Why? Because atom is electrically neutral because of the presence of equal number of protons and electrons. So the subatomic particle which is present in atom which shows positive charge is proton. The subatomic particle which exhibits negative charge present in the atom is electron. So when the number of protons and number of electrons are balanced, so automatically atom will be electrically neutral. So in this case, if you observe the options, first one, number of electrons and protons are unequal, no. Number of electrons and number of protons are equal, yes, because of the presence of same number of electrons and protons in the atom, atom is electrically neutral. Look at the option C and option D as well. Number of electrons and number of neutrons are equal, no, neutrons are chargeless particles. The charged particle present in the atom are proton and electron only, neutrons does not have any charges, okay. Third one, if you fourth one, if you observe, number of protons and number of neutrons are equal, no, it is not at all related with the protons and neutrons, or not related with the electrons and neutron. The neutrality of an atom is related with the number of protons and number of electrons, because electrons are negatively charged spaces, whereas the protons are positive ones, okay. If they are equal, then they can balance their charges, thereby the atom is electrically neutral, okay. Which of the following can take part in a chemical reactions? We have discussed while we are dealing the differences between the atom and ion. Which one will take part in a chemical reaction? Generally atoms will take part in a chemical reaction. It is not the molecule or ion or the neutron, it is the atom that is going to take part in the chemical reactions. Dalton is the first person who has proposed the atomic theory. So in his atomic theory he has mentioned that atom is the particle which is going to take part in the reaction. So atom, of course, that statement given by Dalton in those days is still valid, because atom is the only one which is going to take part in a chemical reactions, okay. Which of the following is stable in its atomic state? Stable in atomic state, okay. They are asking us which of the following generally exist in nature as atom, not as a molecule. We know that molecule, how the molecule is going to form? Molecule will form by the combination of atoms. So whenever atoms combine, combination of atoms always result in the formation of a molecule. So, the atoms which are unstable generally they look for another atom and they will combine. So, atoms will combine in order to get the stability. The main funda to acquire the stability is the acquiring or the formation of molecule is stability. So, towards the stability the atoms will drive. Okay. So, in order to get the stability they combine with one another. So, atoms combine in order to get the stability. So, thereby combination of atoms result in formation of a molecule. But in this question what they are asking, which of the following exist in nature as atomic state? We know oxygen in nature exists as O2 molecule. It will not exist as oxygen atom because oxygen atom is unstable. Oxygen molecule is stable. So, two oxygen atoms combine together and form oxygen molecule. Nitrogen, we know nitrogen in nature exists as N2 gas, nitrogen gas N2. Nitrogen cannot exist in nature as a nitrogen atom. Okay, nitrogen exists as nitrogen molecule in nature, right? Neon, yes, neon is the noble gas which exists in nature as Ne only. We cannot expect Ne2 or Ne3. Combination of neon atoms is not possible. Neon will exist in nature as atomic state only. So, neon exists as Ne. Look at the other one also, phosphorus. Phosphorus in nature will exist as P4 molecule. So, 4 phosphorus atoms will combine together and give phosphorus as a P4 molecule. Okay. So, here if you observe among the given options, neon is the only species which exist in nature in a stable form, that too in atomic form. Okay. So, this is noble gases, all noble gases if you observe, helium, neon, argon, krypton, xenon, radon, all these are monoatomic gases. They are stable in atomic state in nature. Okay. So, whenever these kind of questions are given, easily identify one of the options should be the noble gas. Okay. So, neon is the correct answer for this particular question, right. Next one, which of the following is a homonuclear molecule? What do you mean by homonuclear? So, here the nucleus is homo, that is to say that, so it is a molecule that is formed by the combination of atoms of one element only, atoms of one element. When one element atoms combine together result in the formation of homonuclear species. Whenever we have a molecule with atoms of different elements, when atoms of different elements combine together we always get a heteronuclear molecule. So, what they are asking? They are asking to identify homonuclear molecule. So, which is homonuclear molecule? Let us write the formulas of all these given compounds so that we can easily identify. Water, we know it can be written as H2O. If we observe the water molecule, 2 hydrogen atoms and 1 oxygen atoms. Atoms of hydrogen, atom of oxygen are combining. So, atoms of different elements are present. So, this is a heteronuclear molecule. It is an heteronuclear molecule, water. Okay, right. Ammonia, ammonia is NH3. Ammonia is NH3, 1 nitrogen atom, 3 hydrogen atoms are combining, atoms of different elements, hydrogen element as well as nitrogen element are combining. So, it is also a heteronuclear molecule. Okay. Now, oxygen, we know oxygen in nature exists as O2. So, here oxygen atom and oxygen atom are combining, atoms of oxygen atom, oxygen molecule element only combining, we are getting oxygen molecule. So, this is homonuclear molecule. Okay. Let us look at the fourth option as well. Methane, methane we represent with a CH4. Here 1 carbon atom, 4 hydrogen atoms are combining together, atoms of carbon and hydrogen are combining. So, atoms of carbon and hydrogen are combining. So, it is an heteronuclear molecule. So, among the given options, which is homonuclear molecule? Oxygen is a homonuclear molecule. In case of oxygen, 2 atoms of oxygen are combining, of atoms of only one element are combining, thereby we are getting the oxygen molecule. So, oxygen is a homonuclear molecule, water, ammonia, methane all are heteronuclear molecules, right. Number of electrons in, they have given the symbol, that is sulfide ion, sulfur with 2 negative charges we call it as sulfide ion. So, we have to identify the number of electrons present, okay, right. Sulfide ion, so we can write the sulfide ion, sulfur with the 2 negative charges is sulfide ion, it is S minus 2. So, downside they have written 16 and upside they have written 32. So, whenever we have an element, when we write an element generally we write the atomic number and atomic mass as this way. So, here it is indicating atomic number. What is atomic number? Atomic number is nothing but it is the number of protons present in the nucleus. So, here clearly indicate the Z value. Z value indicates number of protons. Okay. What is A? A is indicating number of protons and number of neutrons. So, it is a sum of neutrons and protons. A is sum of neutrons and protons. So, whatever may be the charge that is present, if since it is a neutral species, I am not representing any charge. When we have a charges, positive charges means less number of electrons are present than that of the protons. When we have negative charge, in that case more number of electrons are present than the proton number, right. Let us look at this one, sulfide ion. So, this one is atomic number. So, we can write the number of protons are 16 in this case. Okay. What is 32? 32 is a combination of neutrons and protons. Protons plus neutrons equal to 32. Already we have 16 protons, 32 is the sum. So, when I subtract 16 from 32, what is we are going to get? Neutron number. So, neutrons are 16, right. What about the electrons? For suppose if we are going to have a sulfur atom in this fashion, when there is no charge is present, no charge is present on the sulfur atom, we represent this way. So, no charge means in that case number of protons and number of electrons are same, but here we have how many negative charges? We have 2 negative charges. So, here 2 negative charges means 2 more electrons are present, 2 more electrons are present than that of the proton number. So, already proton number is 16. If sulfur atom is neutral, electron should be 16, but sulfur atom has 2 electrons excess, 2 negative charges excess. Already 16 number of protons means 16 electrons are present plus 2 more electrons. Total will be 18 number of electrons. So, how many electrons are present in the case of sulfide ion? Sulfur with the 2 negative charges, we are going to have 18 electrons, 16 protons, 16 neutrons. So, in total if you observe, sulfur has 18 electrons. So, option is fourth one, that is D. Okay. It does not it has 16 protons. If it is neutral species, then we can expect only 16 electrons, but it is not a neutral species. How many negative charges are present? How a negative charge is obtained generally? Generally negative charge is obtained by addition of 2 more electrons. When sulfur takes 2 more electrons, sulfur will convert into S minus 2. This we have discussed while we are dealing the ions. Okay. So, sulfur is converting into S minus 2 by taking 2 electrons. Already it has 16 electrons plus 2 more electrons. 16 plus 2, 18 electrons are present in the case of sulfide ion. Okay. So, by the symbol we can easily identify Z value indicates the proton number, A value indicates the sum of protons and neutrons. So, we can predict all protons, electrons, neutrons if the symbol is given like that. Okay. It is easy to predict the number of, if the species given is neutral, proton number and electron number is equal. Okay. That can be obtained from the Z value, the down one value. Okay. And neutron number can be obtained by the subtracting a proton value from A. Okay. Right. Molecular mass of nitric acid is, just now we have written the nitric acid formula as HNO3. Okay. So, what is the molecular mass of HNO3? Hydrogen mass is, so if I want to calculate the molecular mass, what I have to do? Whenever we go for calculating the molecular mass, we add the atomic masses of all the atoms present in the molecule. So, how many hydrogen atoms we have? We have 1 hydrogen atom, 1 into atomic mass of hydrogen is 1U plus. How many nitrogen atoms we have? We have only 1 nitrogen atom. What is the atomic mass of nitrogen? It is 14 unified mass. So, 14U plus. So, how many oxygen atoms we have? 3 oxygen atoms into each oxygen mass is, atomic mass is 16U. So, go for 1 into 1, it is 1, 14 into 1, 14. Okay. So, this will be 1 plus 1 into 14, 14 plus 16 3s. See 8, 48. So, 48 plus 14 plus 1. So, this will be 12 plus 1, 13, 3 plus 1, 5, 6, 6, 3U. So, 63 unified mass, 63 unified mass is the molecular mass of nitric acid. So, 63 is first option. So, first option is the correct in this particular question. Okay. So, molecular mass calculation, once you know the formula, since here they have not given the formula, they have given the name nitric acid. So, first we have to get the formula. If you know the formula, we can go for the addition of all the atoms, atomic masses of all the atoms present in the molecule, then we get the molecular mass. It is very simple. So, we can easily obtain the molecular masses by knowing the formula of the species or the molecule to which we have to calculate. Once nitric acid is given, it is hydrogen. So, nitric acid means it is a combination of hydrogen and nitrate ion. So, first you can write the hydrogen and nitrate ion side by side, write the valencies and then go for the dividing the valency with the highest common factor and then get the simple ratio you can get and exchange the simple ratio with the species involved in the molecule, you will get the formula. From the formula calculate the mass. So, you can do in that way also, but of course, you can easily remember some of the molecules you have to remember like hydrochloric acid HCl, sulfuric acid H2SO4, nitric acid HNO3, phosphoric acid H3PO4, okay, sodium chloride NaCl, sodium carbonate Na2CO3, sodium bicarbonate NaHCO3, calcium carbonate CaCO3, calcium bicarbonate CaH plus CO3. So, these things you have to you have to easily make a formulas by taking the valencies. You have to remember because these things will be repeated again and again. Sodium hydroxide NaOH, calcium hydroxide CaOH taken 2 times. So, these things have to be repeated. Once you practice writing the chemical formula, you can easily remember the formulas. Of course, writing the formulas is based on the valency of the species involved in the formation. Okay, right. Which of the following is an anion? Anion. So, in the previous class we have discussed that atom whenever takes electrons, when electrons are added to it, atom will convert into anion. Similarly, whenever electrons are taken away, removed from the atom, it will result in the formation of cation. So, when electrons are removed from atom, results in cation. When electrons are added to the atom, it results in the anion. So, formation of anion and cation is easy. So, what we have to do? We have to identify anion from the following. So, first let us write the symbols as the formulas for these ions that are given. Hydroxide ion, just now we have written sodium hydroxide formula. In that case, we have taken the hydroxide ion as OH, negative charge. So, this is anion. Okay. So, we got the answer, but let us move on to the other species also. Let us write the formulas so that you can easily identify them. Sodium ion, sodium is Na, it is a metal. So, it is going to lose an electron and forms Na plus ion. So, it is a cation, not anion. So, this is ruled out. Ammonium ion, just now we have written the ammonium chloride formula. Ammonium ion is NH4 plus, is ammonium. So, this is also a cation, right. Hydrogen ion, hydrogen H plus, that is proton, H plus hydrogen. So, hydrogen ion H plus. So, all sodium ion, ammonium ion, hydrogen ion, all are having positive charges. Hydroxide ion is the only ion which is having negative charge. So, negative charge is obtained only by accepting the electron. So, what is anion in this case? Hydroxide ion is the anion in this particular given species. Okay. Right. Let us move on to the next question, the molecular mass of sodium hydroxide to be calculated. Sodium hydroxide, just now we have derived the formula NaOH is sodium hydroxide. So, how to get the sodium hydroxide molecular mass? Sodium hydroxide molecular mass can be obtained by the adding the atomic masses of sodium, oxygen and hydrogen. When you add atomic mass of sodium, atomic mass of oxygen and atomic mass of hydrogen, we are going to get the sodium hydroxide molecular mass, right. Let us write how we are going to calculate. So, the molecular mass here can be given as molecular mass equal to 1 sodium. How many sodiums we have? We have 1 sodium. So, 1 into what is the mass of sodium? Sodium is 23. What is sodium? Sodium mass is 23, okay, plus how many oxygen atoms we have? We have only one oxygen atom, 1 into 16, okay, plus how many hydrogen atoms we have? 1 hydrogen atom into mass of 1 hydrogen atom, 1. So, if you write the mass, it is 23 plus 16 plus 1. So, 23 plus 16, it is 39, 39 plus 1, 40. So, 40 unified mass is the mass of sodium hydroxide. So, what is the mass of sodium hydroxide? Sodium hydroxide mass is 40 AMU. Of course, nowadays we are replacing the AMU with a unified mass. So, it is, let us take it as AMU only, atomic mass unit, 40 atomic mass units, 40 AMU. So, molecular mass of sodium hydroxide is 40, it is not 140, 60 or 80, it is 40 U only. Okay. So, calculation of molecular masses, I think you have got a clear idea how we are going to calculate the molecular masses, because these kind of questions we can expect in the main level examinations. Okay. Right. And of course, we can expect advanced level questions as one or more than one type answer type of questions. So, they will give us options. Among the options, at least not only one, even more than one option may be correct. So, we have to identify all the correct options from the given options. It is not choosing only one correct answer from the given 4. Okay. So, in this case we have to choose at least the given options, among the given options 1 may be correct, or 2 may be correct, or 3 may be correct, or even 4 may also correct. So, that kind of questions we can expect in the advanced level questions, one or more than one answer type questions, one or more than one type questions. So, in few cases only one answer may be correct. Okay. In few cases we get 2 correct answers, in few cases we even get a 3 correct answer, in few cases even we get 4 correct answers. So, all these answers has to be correctly chosen, correctly we have to identify the given options. Okay. Right. Which of the following is correct about uranium 92 and 238? They have given a symbol U, U means uranium. Uranium atomic number is 92, atomic mass is 238. So, they have given us the symbol. So, once they have given the symbol, and if you observe, the uranium does not have any charge, it is a neutral atom. Neutral uranium atom is given with atomic number 92, atomic mass as 238. Just now we have observed that whenever we have a element, whenever we have an element with this kind of symbol, so what we have to identify? The atomic number and atomic masses generally written in this fashion. So, the lower one is atomic number, upper one is the mass number. Okay. So, what is atomic number? Atomic number is nothing but the number of protons present in the nucleus of the atom. So, here atomic number is 92. What does it indicate? Atomic number is 92 means the number of protons are 92. So, we can write it as number of protons equal to 92. Okay. Number of protons equal to 92. Now, A, what is A? A, I just now told you that it is a sum of protons and neutrons, sum of protons and neutrons. So, once we know the value of proton, can we calculate the number of neutrons? Yes, we can calculate the number of neutrons as neutron equal to A minus P. So, by subtracting number of protons from the atomic mass, we can easily identify the number of neutrons. So, the number of neutrons in this case is 238 minus 92. 238 minus 92, if I take, it will be 16, 13, it will be 4, it is 146. So, 146 is the number of neutrons. Since it is a neutral atom, what will be the number of electrons? Number of electrons, protons and number of electrons values will be same. Now, look at the options. The number of protons present in the uranium atom is 92. Yes, it is correct, because atomic number is 92, it is correct. Okay. Number of neutrons present in the uranium 238 is 146. Yeah, just now we have calculated 146 is the number of neutrons. So, this is also correct. Look at the third one. Number of protons present in the uranium 238 is 238. No, this is wrong. Okay. and number of neutrons present in the uranium 32 is 90. No, number of neutrons what we have calculated is 146. So, this is also wrong. So, A is correct answer, B is also correct option in this particular case. So, these kind of questions we can expect in the advanced level examinations. Student, I think you have following what I am giving you the concepts, right. So, please be in touch with the regular classes.